Okay, so after identifying a problem, the next step to solve it scientifically is to formulate a hypothesis. That's our discussion for today as I describe hypothesis so we can formulate a good one. So what is a hypothesis? Hypothesis is defined as a tentative explanation which can be verified by further investigation, or this is just an educational guess. I would like us to take note of these three terms: tentative, verified, and investigation as we evaluate this definition and understand better what hypothesis is. So, hypothesis, when I say tentative, a hypothesis is just a possible answer to a question or a possible solution to a problem. Therefore, it's not yet the final answer or the final solution. It must be verified. We have to know if it's correct so we can accept it, or if it's wrong so we need to reject it. Also, if our hypothesis is wrong, we need to formulate a new one. So, how to know if it's wrong or if it's correct? We need to conduct an investigation, or this is just an experimentation. An experimentation is done to test the hypothesis. This is the main purpose why we do experiments. We conduct experiment to test a hypothesis. So that's the definition. Next question. What are the characteristics of a good hypothesis? A good hypothesis is testable, logical, and specific. So when we say testable, it means it can be measurable, and scientific concepts and principles are used as basis for it to be logical. And specific means one property or parameter is measured at a time. So let's have an example to better understand a characteristic of a good hypothesis. So previously you were asked to formulate a hypothesis using the if then because format of this question. Which size of 10-gram sugar, the granulated or the powdered sugar, will dissolve faster in water? That's the question. So with this question, we have this hypothesis. If the particle size of sugar is increased, meaning from smaller particle granulated, powdered, to bigger particle size, which is granulated, then the dissolution rate of sugar is decreased, meaning sugar is dissolved slowly. But we can also use increase, or sugar is dissolved faster, because less sugar particles are exposed to water. So let's check if it's testable, logical, and specific. Okay, can we measure the rate of dissolution? If it's slower or faster of dissolving sugar as we change the particle size of sugar, meaning can we have the powdered sugar dissolved in water, and then can we measure the time at which it is dissolved? And we have another setup for granulated one, still dissolved in water, and then measure. Can we do that? Definitely we can. That's why this hypothesis is testable. Then, based on the hypothesis, surface area or exposure of sugar particles to water and how it is affected by particle size is being expressed. Therefore, this hypothesis is considered logical. Also, to be for a hypothesis to be specific, known and specific property must be measured, and in this hypothesis, the dissolution rate. So we should specifically measure the rate of dissolution, or the time at which the particles are dissolved, which is being stated in the hypothesis. Therefore, it is specific. Thus, this example or this hypothesis is considered as a good hypothesis. Next, how to express a hypothesis. Hypotheses are expressed differently, and the if then because format is just one of them. We can also express hypothesis in terms of non-relationship between two properties. For example, we have here number of pets and number of people as the two properties, and we express their non-relationship in this way. the number of pets in a household is unrelated to the number of people living in it. So that's one way of expressing a hypothesis of non-relationship. But we could also actually express a hypothesis in terms of the relationship between two properties. For example, let's have the second one. A person's preference for a shirt is, instead of saying unrelated, you could say is related to its color. So that's also another way of expressing a hypothesis. But the if-then format is like a cause and effect statement. So let's use this one. So that's how we formulate a hypothesis. So identify a problem, formulate a hypothesis, and the next step is we need to know if it's correct or wrong. We need to test the hypothesis. So the next step is we need to conduct an experiment or fair testing, which is our next discussion.